So today we're going to look at a little more detail on sinusoidal functions. So here's a diagram of a model of a sinusoidal functions, and sinusoidal functions, the domain is actually all real numbers, and the range has a specific lowest point and a highest point. So let's look at these features. So amplitude, the first one is amplitude. And amplitude is the distance of the sinusoidal model that rises and falls above the midline. So if you take a look at this, this is the midline. We also call it the principal axis. So this is the line where it cuts through the sinusoidal functions, basically in half horizontally. So that amplitude is actually the distance from that midline to the maximum or the midline to the minimum. So there we go with the amplitude and the midline. So let's look at the period. We talked about period before, and period is the distance of one cycle. So wherever you start, you have to end at the same height. So this is one cycle, so period is the distance. Now I didn't have any measurement that is written on the x-axis, so here we're not going to determine it, but period is the distance of one cycle. Now frequency is something new that we haven't really talked about too much. Now the frequency is actually the number of cycles completed from 0 to 2 pi. So the frequency is how many cycles are there in the length of 2 pi. So let's take a look at the example here. So here's a graph of a sinusoidal functions, and we'll talk about specifics of sinusoidal functions in the next few lessons. But let's look at this and let's determine where is the midline. So first, to determine the amplitude, period, and the frequency, midline is important. So we're going to determine that midline first. So let's take a look at actually the lowest point and the highest point. Now I can see that the lowest point is at -6 and the maximum, the highest point is at 2, which means that the distance from the minimum and the maximum is 8 units. So probably the midline is going to be somewhere over here. So right over here. So that will be our midline. Now, what is the equation of the midline? Well, it's the horizontal line that goes through -2, so it's going to be y equals -2. Okay, so there we go. So we have the midline. Now, what about the amplitude? Amplitude, if we go back to our definition, the amplitude is the distance of the sinusoidal model that rises and falls from the midline. So what is the distance from the midline to the max? It would be 4. So next, let's look at the period. Period is the distance of one cycle. So let's look at it and see what would be the distance of one cycle. Now, you can start again from anywhere. Let's say if I start from here, then this one cycle ends about right over here. So it looks like it's about pi distance. So this has some distance. This seems like it's the same distance. So this cycle, one period is going to be 1 pi. So this is pi. Okay, so one cycle is pi units. Lastly, let's look at the frequency. Now, frequency is how many cycles are there in 2 pi, in the distance of 2 pi. So let's take a look at from 0 to 2 pi. So we want to look at the length or how many cycles there are from 0 to 2 pi. So from 0 to 2 pi, you count how many cycles it went. So it looked like 1 and 2. So this one looked like it went 2 full cycles. Now, some doesn't always have to be a whole number. It could be 1.5, it could be 1.25, but in this case, it's looks like it's 2 cycles. Now this one has actually some kind of a shift, horizontal shift as well. So this one actually doesn't shift as exactly on the grid. So that's why there's a little bit of a space, but this one looks like it's the same unit. So it's approximately 2 is the frequency.